For this next lecture set, we will talk a little bit more about working memory. So when we use working memory, the easiest way to think about this is whenever we're holding more than a single item of information in mind, we are using our working memory to keep track of those multiple instances. Now, you could be looking at a row of string, for example, and not thinking about it at all. And well, maybe then in that case, you're not using your working memory system, even though people would argue that even then you are. As soon as you start thinking about the string itself that's on that table, you're using your working memory system. Now, when it comes to our abilities with working memory, there is a fair degree of individual differences in our ability. Now, fair in the sense of a statistical difference, but not necessarily in vast, huge differences. Meaning you're not going to find people who have working memory capacities that allow them to store hundreds of items versus only 2 items, for example. Even though there are people who perform unbelievably well at memory competitions, for example, but as we'll talk about in this lecture, that is not so much that they have unbelievably amazing working memory, even though some people have better working memory than others, but rather they know a series of interesting skills that allow them to use their working memory to really its maximum capacity. Even that's misleading because almost all of us are always using our working memory to maximum capacity. It's just the efficiency with which we store information in our working memory or operated on that information is what is different across individuals, which results in those large differences we tend to see of people's ability to remember. Now, one of the earliest measures of working memory, and this was often used when we were still thinking, even though it's used a lot today, but this originally arose when we thought about short-term memory as opposed to working memory. And this task is referred to as the digit span task. You'll still find this all over. It's technically still included in the WAIS 4 IQ test, which is, I believe, the most modern version of it. And the way this works is that you have a participant listen to a couple of numbers, so like 2 and 7, let's say, and then as the participant, you just repeat 2, 7 back, and it has to be in the correct order. And now, if you're able to do that successfully, which many of us are, you're given a new sequence of numbers that is one longer, so like 3, 9, 4. And then you would repeat that back, and you'd say, okay, 3, 9, 4. And after you gave a correct response there, you would get a new sequence of numbers that is one number longer. And you would keep doing this process until you made a mistake. You're allowed to use as much time as you want, well, within reason, of course. So if you have to sit and think for a minute to get the last couple numbers, that's totally fine. Where one stops is as soon as one has made a mistake in either the correct numbers or the order in which those numbers are presented. And on average, people are able to remember about 7 numbers. Well, within some range, where some people tend to remember a few more and some people a few less. And this is where that statement of we're able to hold 7 plus or minus 2 things in mind comes from. Because on average, with one standard deviation to either side, was 7 numbers with a standard deviation of 2 numbers. Now, there are some people who can just blow this 7 out of the water. For example, there is a person who was required to do this task, and they were able to remember as many as 70 digits correctly in the correct order, which is pretty unbelievable, and it seems pretty hard to imagine how they could have a working memory system that is allowing them to remember so many individual pieces of information. And our automatic response here is oftentimes they just have an amazing memory. And while they do have a really good memory, it's not as simple as just they have way more sort of save spots in their working memory system than the rest of us. In order to understand what's going on, one has to think about chunks. And chunks are deliberately unscientific because, well, there's no exact definition of what a chunk actually is, but this is just a way to refer to the smallest piece of information that's held in working memory. But now, what smallest is different for everybody. Not necessarily that you can hold a mouse versus an elephant in memory and something like that, but rather the complexity changes and the relationship changes between these various items. Now, take the following example. if you were asked to remember the letters P-E-T-A-L-S in the correct order, this would take 6 chunks of information. You have one for P, one for E, one for T, one for A, one for L, and one for S. And you could remember each of these individual letters, and you could repeat them over and over, like P-E-T-A-L-S, P-E-T-A-L-S, and just keep going over and over and over. Or you could just remember one word, petals. And when you had to think about the list of letters, you could just think to yourself, oh, okay, it's basically spells the word petals, and so that's P-E-T-A-L-S. And I could now devote all that extra space to something else, because all I have to do to get all 6 letters back is just think about the word petals. And so in the case of making my smallest chunk into petals, all of a sudden I have increased space in which I can hold other pieces of information. And both the P and the word petals in either case is just the smallest chunk. And so here you can see that modifying the way you're holding information in working memory can change how much one is able to remember. Pretty straightforward for words, but how was the person doing it for 70 digits? Because they were actually doing something quite like this. And it turned out that this person just really loved keeping track of race times and watching races and remembering certain races in particular and so on and so forth. And they just converted all the numbers they kept hearing into race times. So for example, as soon as they got the list 3294, they just remembered, well, that's 3 minutes and 29.4 seconds. And of course, you can imagine that as soon as one more number is added, it could just become 32 minutes and some degree of seconds, but it can't be 94 seconds because that'd be kind of weird. But I guess you could make it like that anyway, because who cares in your way of memory if you write 94 seconds and it's 32 minutes instead of saying 33 minutes and 34 seconds, right? But in this way, when you're just thinking to yourself, well, it's 3 minutes and 29.4 seconds, that's only a single race's time, which is just one chunk in your memory system now, instead of those 4 separate numbers. And in this way, one can have a dramatically increased amount of individual units of information that can be accessed in your memory, even though you're now using still that same few items or spaces you can store information. You're just using those spaces much more efficiently. Now, this is not an innate skill. Yeah, it's not innate. I'm just thinking about if the word innate there is correct. Anyway, this is a skill that can be practiced and taught, right? People can practice this skill with all sorts of memory and get better and better and better. And many people tend to view memory as a construct like intelligence that is fixed, that you either have good memories or bad memories. And this is just simply not the case. It is oftentimes we have bad memory because we're distracted or not paying attention, or because we're being inefficient at how we're trying to remember that information, not because we actually just have some kind of neurological deficit compared to somebody with a good memory. Oftentimes people with good memory just have well-practiced skills in order to remember lots of information, along with paying attention to the information they're trying to remember. To see some unbelievably wild-styled examples of this, I highly recommend checking out performance at memory competitions, and you will see that these people can perform some unbelievable feats. Stuff like remembering 500 digits in a row with only 5 minutes or 10 minutes to remember all of those digits. And you will see that people do quite well. And if you listen to some of these people talk about how they do it, you will see that they do it through very particular strategies in order to allow them to remember this complex series of numbers or other information. And while it takes effort, it is a learnable skill, just like learning to play the piano or to play tennis or pretty much anything else in life. Now, I did refer to the idea that the digit span task arose when we were still thinking about short-term memory as short-term memory, and as we've moved our conception away from short-term memory into working memory, we needed a better operational way of figuring out how big the storage capacity of working memory was. And so this led to the creation of something called operation span. And it's very similar to the digit span task, where you're given a sequence and you're asked to repeat the sequence or something in the sequence. And then for each successful iteration, you're given a new sequence with one additional piece of information. Now, here though, the difference is you're often required to operate on each of those sequences in some way, thus using your working memory in order to solve any of these sort of responses that are required. So here would be an example of how this would work. And so here you're seeing various sequences of math. So here you have 7 times 7 first plus 1 equals 50. And so you'd be asked to determine if this statement was true, and then also the word dog. And then let's say you were given another one, which is 10 divided by 2 plus 6 is equal to 10, which would be false, and then gas. And so the way you would respond to this would be true dog, false gas. And if you did that, you would be given a new sequence where you had these two plus, now let's say another one where you had 4 times 2 plus 1 is 9 with nose. And so here I would say, after remembering this list, because this is what's presented to me, I would be like true dog, false gas, true nose. And this is the way in which I would respond back. And there are many, many different varieties of Operation Span, but all of them have this in common. They all require the presentation of a certain sequence or piece of complex information that requires some degree of processing to be applied to each of those individual pieces before you can then respond back. Now, of course, this is much more difficult than just the digit span task, but people are surprisingly good at this too. I mean, good in a relative sense of where we're not doing hundreds of these, even though, again, there are some really cool strategies to just blow this stuff out of the water. But nonetheless, one of the advantages of using this, not only does it fit more theoretically with our conception of working memory, but this measure of working memory is actually much more predictive of real life events than digit span, which is not actually related to most of the things we do in real life. For example, performance in the operation span has been linked to both intellectual performance and academic achievement, and it is also related to just general problem solving ability in the world itself. And I mean problem solving not just that you can do a mathematical problem, but anything from being able to figure out a route to go when you hear on the news that there is an accident somewhere, or trying to figure out what type of recipe to use now that you can't find a certain can of chilies at the store. Right? These are all also problem solving abilities, and our performance at solving those problems is actually fairly highly correlated to our ability to perform in this operation span task. Now, our ability to perform well or not on the digit span task, just repeating those numbers back and forth, is actually not related to any of these concepts in any meaningful way. And one fun extra piece that this allows one to take away from is it makes one wonder how much of our IQ tests are actually just studying our ability to perform these types of operations and exercise our working memory, and might have less to do with just the trait of intelligence itself, as opposed to just how well we have trained our working memory system, which again, remember, is a trainable system. But also, at the end of the day, intelligence is fairly malleable, even though many people don't think about it like this, and they're just highly related. And it just goes to illustrate how intelligence is not just this one thing that you're either intelligent or not, or more or less, but it's actually a much more complex integration of all types of different systems. We'll talk a bunch more about intelligence at the end of this semester. One last note to make is about the working memory system and the central executive, or executive function, or executive control. And these two systems, so the working memory system and the executive function system, are very closely related. You hear them talked about together all the time. Correlations between tasks that are meant to evaluate one or the other are oftentimes very highly related, or strong correlations. And so they get talked about together a lot. Now, that doesn't mean they're the same thing, though. So just a reminder of executive function. Remember that this system is brought online whenever we're making plans, whenever we're keeping mental items in correct order, whenever we're engaging in behaviors that are different from our original habits, or when we're trying to just learn new skills and behaviors. And if you think about each of these items, all of them requires that you hold information in working memory. For example, when you're making a plan, oftentimes a plan has more than one step. And so in order to keep track of the different steps, you have to hold those steps in working memory. Same thing with keeping either the planned steps or just other mental items in correct order. Not only do you have to know what the items are, which you're holding in working memory, but you also have to have information about their relationship, meaning some come before others. Same thing with trying to break out of habits, right? You do your habit automatically, but then you get a reminder to yourself via some external cue, whatever it happens to be. No, don't do this. I have to do it like this. And then as soon as you're thinking about, okay, how should I do it differently? That's in your working memory. Very similar to when you're learning a new skill, you think to yourself about all the steps required to learn those new skills. And here you can see why these two systems are probably so highly related. But it doesn't necessarily mean that they're the same thing, right? It's just both of these seem to be different functional sets that exist in the brain, and it is also important to know that neither of them hold any one specific neurological location in the brain, right? There's not one place to the brain you can point out and be like, haha, central executive, haha, working memory system. Rather, these are again just complex brain states, which is another way of saying large and disparate regions of the brain are all interacting and they seem to bring about these types of functions. Now, what the actual neuronal overlap is between these two systems and how much of them have some common underlying, maybe third functional system is still a matter of active debate. And as far as I know, there are really no great answers on that one. It's just important to know that these are, again, you're going to hear them talked about together a lot if you pursue this field, but they are not the same thing. But they do, well, the executive functions definitely require working memory. How much of working memory requires executive function? Even there you can make some arguments that otherwise how would you know what things to remember, but that turns out to be a much more complicated process than we might imagine, and we'll get some good examples of that when we start talking about language.